Welcome back from the ad break, and let's continue with our lesson. Now, we were busy with that pre-knowledge practice, so let's continue with that. Let's look at exponents and remind ourselves of how to write numbers in exponential form. So we have there 64. Now, if you remember 64, it can be presented in different ways depending on what we want our base to be. So 64 can be written as 8 exponent 2. It can also be written as 4 exponent 3, and it can also be written as 2 exponent 6. So those are the different ways that we can present our 64. Let's look at our 9. Now, how can we write 9 as an exponent? So 9 is 3 exponent 2, because 3 exponent 2 is 9. What about 216? Now that can be written as 6 exponent 3 or 6 cubed, but it can also be written as 2 exponent 3 multiplied by 3 exponent 3. So those are the different ways that we can write these numbers in exponential form. Let's move on to the next slide. Let's quickly set up an equation. So I've got a word problem here that says the sum of a number and 3 is 11. Write an equation that represents this. So the sum of a number and 3. We know that sum means that we are adding, and we are adding a number that we don't know. So we couldn't use any letter to represent that number. So the sum of a number and 3 is 11. Now we've set up that equation, and you will be able to solve for that equation. What are other ways that we can use to set up an equation? So another way of setting up an equation is when we start with the answer and then we develop that equation. So for example, let's say the answer is x is equals to 2. Now if x is equals to 2, let us multiply both of these values, or the value and the variable, by 4. So if I'm going to multiply both sides by 4, what does that give me? Now x multiplied by 4 gives me 4x, and 2 multiplied by 4 gives me 8. So now I have 4 multiplied by a number is equals to 8. And of course we know that that number is 2 because that's the answer that we started with. But we need to see how an equation is developed. Then from both sides again, we are going to subtract 1. So when I subtract 1 from both sides, on one side, which is the left-hand side, I have 4x minus 1, which means a number multiplied by 4, and then 1 is subtracted from that product. What does it give me? It gives me 7. And where does the 7 come from? It comes from the previous step, which is the 8 minus 1. Now we've set up an equation, and now that equation is 4x minus 1 is equals to 7. Let's do the last one of setting up an equation. Now, remember, we start with the answer and then develop an equation. So let's start with x is equals to 2 again. Now, this time we are setting up an exponential equation where our answer, x is equals to 2, has now been raised as exponents. And now both of them have been given a base 3. And now we are creating powers here where we are going to say we now have 3 exponent x is equals to 3 exponent 2. And then from those, again, we are going to multiply each side by 2. Now, remember, 3 exponent 2 is 9. And when we multiply both sides by 2, what do we have? We have 2 multiplied by the power of 3 exponent x. And this is equals to 18. And that is our equation there. So when we get that equation, we would know how to solve for it because we know where it comes from. Let's look at the keywords that we are going to be using during this lesson. So we are going to use equation, which is one expression that is equal to another expression. For example, x squared plus 2 is equals to 5. Then we have the additive inverse, which is the number that you add to another number to get 0. For example, the additive inverse of a positive 3 is a negative 3 because positive 3 plus a negative 3 is equals to 0. Then we have the multiplicative inverse, which is the number that you multiply with another number to get 1. An example of this is that the multiplicative inverse of 1/2 is 2, because 1/2 multiplied by 2 is equals to 1. Looking again at that concept map, we are now going to be working on the first point, which is solving linear equations. Let's look at solving linear equations, and we are going to look at it as a scale. So as you can see there, we have now a balanced scale. So when we have an equation, it is a balanced scale. But whatever I do on one side of the scale, it will make the scale to become imbalanced. But then I can now add maybe some weight on the other side of the scale, and the scale is still imbalanced. But once I add the same things on either side of that scale, then that is going to cause our scale to be balanced again. And that is exactly how an equation works, right? So the equation must always be balanced. So if I add some weight on the right-hand side, I must add the same weight on the left-hand side. So it's also true about equations. What I do on the left-hand side of my equation, I must go and do the same thing on the right side of that equation. Let's look at some inverse properties, which we already looked at initially in this lesson, but now we are going to look at how we can use these inverse properties to solve for our equations. So when we solve for equations using the additive inverse, we need to, firstly, identify the actions that were taken and reverse those actions to get back to the same place. So if an action was taken, we just need to reverse that action and then we'll get back to the same place. Let's see how we can do that. And as we are doing that, we must remember that like on a scale, what we do on one side, we must go do on the other side. So the inverse operation of an addition is a subtraction, and the inverse operation of a subtraction is an addition. Let's look at the example, x plus 7 is equals to 12. So this is simply saying a number, this is simply saying that 7 is added to a certain number and the result is 12. So how are we going to do this? We have here x plus 12. So we have here x plus 7 is equals to 12. So 7 was added to this number and the result was 12. How do we reverse this process? We are going to need to take away this 7 from there. So from this x plus 7, we are going to take away that 7. It was added, we are subtracting it. And what I do now on one side of the equal sign, I must go and do on the other side of that equal sign. So on this side as well, if I say 12 minus 7, that is going to leave me with 5 on the right-hand side, and on the left-hand side, I have a 7 minus 7, remember, that gives us 0 because they are additive inverses of each other, and I'm just left with x. So x is equals to 5. And if you look at it, if we add 7 to 5, the answer is 12. Isn't that amazing? Let's look at some examples here. And then again, remember, what we do on the left, we have to go and do on the right as well. So now we have x plus 1 is equals to 7. So from this equation, what do we have here? We have a 1 that is added to this number, and the result is a 3. So how do we work with that? We use the additive inverse of a positive 1, which is a negative 1. So if I say a negative 1, so if I add a negative 1 on one side, I have to now go and add a negative 1 on the other side. Let me show that we are adding a negative 1 on both sides. So what is going to happen there? This is going to be x plus 1 plus a negative 1. Now we know that 1 added to a negative 1 will give us 0 because they are additive inverses of each other. And then here we have 3 plus a negative number. Remember, adding a negative number is the same as subtracting the additive inverse of that number. So that is 3 minus 1, which will give us a 2, which means that the number there is a 2. Let's look at the second one here. We have now the 8 minus x is equals to 11. Right? So x was subtracted from 8 and the answer is 11. So how are we going to solve for that? Again, we are going to be working with the additive inverse of a positive 8. So what is that going to be? Now the additive inverse of a positive 8 is a negative 8. So from both sides, we are going to add a negative 8. And now when we say 8 and we add a negative 8, we know that will give us 0. That leaves us with that negative x that is there, or that minus x. And on this side of the equal sign, we have 11 minus 3. Remember, we are adding a negative number, so that is going to give us a 3. Now, we still don't have our x value because of that negative there. And whenever we have a negative number and we want to make it positive, then all we need to do is multiply by a negative 1. Remember, a negative multiplied by a negative will give us a positive, and multiplying by 1 doesn't change the value of that sum. So we are going to now here multiply by a negative 1. And again, what I do on one side of the equal sign, I have to go and do on the other side as well. So even here, we will be multiplying by a negative 1. So what is going to happen here? We have a negative x multiplied by a negative 1. That will give us a positive x. And on the right-hand side of the equal sign, we have a 3 multiplied by a negative 1. That will give us a negative 3. It means that the answer here for x is a negative 3. Let's quickly go to an ad break, and then we'll see you just now for the rest of our lesson.